Next, we're going to talk about how to factor by grouping. When a polynomial has more than 3 terms, so 4 or more, technically just 4, we factor by grouping. So what we do is we group terms that have a common monomial factor using grouping symbols. That's going to be our parentheses. There will usually be 2 groups. You may need to rearrange terms, but that won't always be the case. You're going to factor out the common monomial from each group, and then factor out the remaining binomial factor if one exists. So let's look at this example. I have 4x squared plus 2x squared minus 2x minus 1. I'm going to put in some grouping symbols for these first 2 terms and these second 2 terms, taking the negative with me and rewriting that as addition, right? The greatest common factor of 4x squared and 2x squared is 2x squared. That leaves me with 2x squared times 2x plus 1. The greatest common factor of negative 2x and negative 1 appears to be 1, but we don't like negative leading coefficients. So we need to pull out that factor of negative 1, and we're left with 2x plus 1. If we pull out a negative, we change the signs. This is like factoring out the GCD, but we're doing it twice. So now we see that they have a common factor, 2x plus 1. So I'm going to go ahead and take our greatest common factors and what they had in common. Now, if I was to FOIL this out like we learned in chapter 5, I would get back to where I was before. So the best way to check your answer is by using FOIL. Let's work through a couple more examples. If I have mx plus qx plus my plus qy, I'm going to go ahead and put in my sets of parentheses. The greatest common factor of mx and qx is going to be x. So I pull out that factor of x, and that gives me x times m plus q. So x times m is mx, and x times q is qx. And we'll rewrite our variables in alphabetical order. If I look at my and qy, the greatest common factor of my and qy is y. So I'm going to pull out a factor of a positive y. That leaves me with y times m plus q. This is the factor they have in common. So I collect the greatest common factors, that's what we pulled out, and we multiply that by m plus q. Now, these, if you've factored correctly, right, should look identical, or if there's no way to simplify this any further, then they won't look identical, or you possibly made a mistake. So always check your answers. For this next example, I have mp squared plus 7m plus 3p squared plus 21. So let's put in our grouping symbols. The greatest common factor of mp squared and 7m is m. So that leaves me with m times p squared plus 7. Again, I just pulled out that m. The greatest common factor of 3p squared plus 21 is 3. That leaves me with p squared plus 7. So I've got m plus 3 times p squared plus 7. I collected the greatest common factors and what they have in common. Next, if I have 6ax plus 12bx plus 1 plus 2b, let's go ahead and put in our grouping symbols. The greatest common factor of 6ax and 12bx is going to be 6x. That leaves me with 6x times a plus b plus 1 plus 2b. Well, what's the greatest common factor of 1 and 2b? That's 1. Now notice, these, oh, that should have been a 2b. But notice that these are not the same. One has an a, and one has a 1 instead of an a, right? So this cannot be factored any further. This is already fully simplified and cannot be factored by